This all right. So for our second half, we're going to be talking about the evolution of the web. So I think all of us here know that front end is constantly changing a bit too fast. It seems like every other week when you go and look on the LinkedIn job boards, there's a new framework coming out that they expect you to know. And things have changed so much, even though the web has only existed for a little over 30 years at this point. And sometimes that change is bad, sometimes it's good. Yeah. Yes. Yes. Uh yeah, I was not expecting someone to get it that fast. But yes, I'm dressed up as Mr. Steve himself. Yeah. So there are some web technologies that we kind of have come to take for granted over time. Some things aren't as great now, some things are better. We're gonna go through and see how things have evolved over time. So first things first, this was heavily inspired by some YouTube binging. If you guys ever check out programming YouTube, UI.dev is a great channel. He's has videos going over topics like why Next one or why React one. Basically why certain tools in the front end world became popular or failed to become popular. And that was pretty much what inspired this talk. So if you like what you see tonight, I highly recommend checking out this channel. All right. So first things first, the birth of the internet. Now, when computers were first being invented, people decided that they wanted to be able to connect them to each other and instantaneously send information. Now, this really started in a military sense because it was the Cold War, and we were scared that the Russians were going to come and nuke us. So we realized, hey, if that ever happens and they decide to send their nukes at us, then if our computers are connected in a decentralized network, then there's part of that network is still going to work. And the remaining computers can still communicate with each other if we have a decentralized setup. So that was basically what led to the formation of the internet. The military was like, hey, we want to be able to send information to each other, even if the whole country turns into Mad Max or Red Dawn or whatever your favorite post apocalyptic movie is. So over time, the internet expanded from being purely military research to more of an academic context. So various universities across the country got access to it. Eventually, started seeing companies get access. Um, the National Science Foundation were actually kind of the main stewards of the internet up until the mid 1990s, but it wasn't really something that was accessible to the average person. Um, a very pivotal organization for the internet was CERN. Now, CERN's mostly famous for the Large Hadron Collider, which is basically some kind of like physics device for researching subatomic particles. People thought it was gonna potentially make a black hole when they first made it, but thankfully that hasn't happened yet. Um, However, I would say that CERN in the early 90s did something that had an even bigger impact on the world, and specifically one computer scientist who worked at CERN named Tim Berners-Lee. So basically, this one guy invented HTTP, URLs, and HTML. And with that, we had the web. So this right here is what the first website looks like. The web basically was a way to easily share information over this vast infrastructure that was the internet. Now, one important misconception that some people have is that the web and the internet are the same thing. They're not. The internet is basically all of the infrastructure that the web runs on top of. So anything like the internet protocol, IP addresses, the physical cables that your ISPs like Comcast, AT&T, or Cox use to send information from your house to whoever you're sending your data to, that is the internet. And the web is basically a network of documents. That's what it started as, at least. And as we can see here from the first website ever, which you can click this link here on the slides and it will show you what the first website looked like. It was basically an idea to share documents very quickly. You could click on links and it'll take you anywhere. It's kind of like if you're reading a book, instead of having something that says, hey, refer to this information on page 200, you just click it and you're instantly at page 200. And this was a revolutionary idea for its time, but it was really just a start. Um, with the early internet, though, it really started out as just being literal documents. As you can see, there's not a whole lot of styling here. There's not really any buttons, no way for people to interact with anything. It was really just slightly interactive text. Um, and even formatting wasn't all that great. So CSS didn't exist until 1996, and in order to basically format things on a page, developers had to resort to a lot of kind of hacky workarounds. So one thing that was very common in the 90s was that developers would use tables to lay out elements on a page. So, now with CSS, we have flexbox, grids, all kinds of ways to arrange things on a page. But if you go to like the Wayback Machine and look at any of the HTML from a 90s web page, you're going to see that everything here is just nested tables. So the little photos that we have in the middle, not even all the photos are showing up. This is a 4x4 table right here. The stats section we have on the side, that is a table. All of it was tables because CSS just wasn't at a point yet where you could lay out things easily. And this resulted in even more kind of crazy hacks. For example, sometimes you would need a row in these table to be empty because you didn't want to put an element there. But there was some kind of strange bug where it would essentially collapse on itself. So what did developers do? They created a 1x1 image called a spacer GIF, and it was literally just a transparent image. And what they would do is put that image inside of a table and scale that image up as necessary to basically give them the spacing they needed. So you would do this nowadays with CSS by using something like justify content or space evenly or whichever one of the million CSS elements you use to lay things out. It was really, really hacky and also not really good for maintainability. And some styling elements were handled directly in HTML. So we had an HTML tag called font that would allow you to specify the font. It's deprecated now. You use CSS for that. Things like Marquee and Blink basically show these kind of tacky, outdated looking animations. Little scrolling banners like this. This is what a marquee is. Used to be a lot more common on web pages in the 90s. And now, if you wanted to make this, which I don't imagine anyone would unless they're like doing it ironically. Um, if you want to make this now, you'd use CSS animations. Okay, yeah. Honestly, I don't think it's that bad personally, but like, we're supposed to promote modern design, I guess. Give me 1 second so I can get my water. But yeah, so before CSS, styling had to be done directly in HTML, either with some now deprecated tags or weird hacks. But eventually we did get CSS around 1996, and it was pretty nice. So we basically went from having documents to really pretty documents. And that was kind of what defined the first era of the internet, known as Web 1.0. Basically, if you visited a website, it was going to be the same experience for everyone, right? And it works good for some things like blogs or newspapers, but there's really no opportunity for interactivity. People can't go in and upload their own content. If you went to the New York Times, that would have been perfectly doable to publish a newspaper with 90s web technology, but you only read the content that the publisher gives to you, and there's really no way for you to interact with it. Some people called it the read-only web. And again, even when CSS was added to the mix, that's all it was, basically just a really pretty PDF. And this is a far cry from how we know the web today, otherwise known as Web 2.0, where we basically have full-blown apps running inside of the browser. Everyone gets a customized experience. Users can upload their own content. So that would be sites like YouTube, Facebook, Instagram, basically the social media age where anyone can easily upload their own content. So there was a bit of a gap between the 90s and what we have today. web technology had to come a long way for the internet as we know it to exist. So how did that happen? Now, first thing you're probably thinking is JavaScript. Now, believe it or not, JavaScript's first iteration was written in only 10 days, which I'm sure a lot of you guys are probably thinking that explains a lot. Was originally written by a guy named Brandon Ike, who I'm probably mispronouncing his name. Basically, he was working at an old company called Netscape, which was basically the predecessor to Mozilla. They used to have a browser called Netscape Navigator in the 90s, which kind of got beaten up by Microsoft and Internet Explorer until they were kind of reborn in the early 2000s as Firefox. But Netscape was really kind of the first major, really popular browser. And they were trying to add scripting, client-side scripting to it. And that was basically what this guy was tasked with doing. And it was very rushed, which again explains why JavaScript is so janky as it is, because a lot of the early design decisions were essentially baked in. It's also a cautionary tale on the importance of maintainability and trying to really prioritize good design decisions up front. But it was what it was, and we got JavaScript. So this was really big because you can now run code directly in the browser. You could dynamically change the HTML elements that you had on your screen. It wasn't just a newspaper where you could instantly flip to another page. However, you're probably thinking, well, okay, we got JavaScript in the 90s. We use JavaScript today. Is that pretty much the end of the talk? No, because JavaScript wasn't actually used for a lot in the early days of the internet. Basically, a lot of the browser APIs that allowed JavaScript to work weren't fully fleshed out yet, and it just wasn't powerful enough to do a lot of the things that people wanted out of the web. So how did web pages work? Well, first things first, templating. So this is basically where your backend web server injects data into an HTML page. And what it does is it allows each user to get a custom page depending on the URL they access, depending on their cookies. It basically made it so that different people would have a different experience on the site. So let's say you're the user right here, and I wanted to look at SSD's LinkedIn page. Basically, the way this would work is we make a URL request to LinkedIn's web server, right? It will process our URL. It says, okay, they're asking for the page that has a username SSDUF. It's going to go ahead, look in its database for some info about SSD. And when it finds us, it's going to go back and put that data into an HTML template. Now, once it's basically made this template, it's going to send that HTML string back to us. And then once we get that HTML in our browser, it's going to render it. And that's basically how early web apps worked. And really, even some web apps today still do this. This pattern is called server-side rendering or templating. And this process is entirely almost on the back end. You don't even need any JavaScript to do a very basic version of this. You basically just request a URL, backend figures out what you want, and then it sends you some custom HTML that generates on the fly. Now, to make this more generic, again, the process is you send some HTTP requests to the server, it looks in its database, and then it sends you something back. So it was a lot more shifted towards the backend. And a very popular kind of pattern for doing this was called MVC. If you ever hear anyone talk about the words MVC in the context of web development, this is what they're talking about. MVC it doesn't really apply to things like React as much. Where basically the controller is a part of your backend that's handling these requests. The model is anything that's doing data processing, and then the view is basically responsible for putting that data into an HTML template and then giving you some HTML to look at. So PHP, if you guys have ever heard of it, it's one of those things that sounds outdated now, but the reason it got popular in the first place is because it was really good at templating. You could actually do this with any backend frameworks. Some of the older ones that were more popular in the 2000s were, again, as we said, PHP, Django for Python, Java server pages or a .NET with C#. But any of the more modern backend frameworks are also capable of doing this. So Node.js, you can do this. Golang standard library, you can do this. And again, no JavaScript at all yet. You can get a basic web app working where you have some interactivity between the user and the server, and everyone's getting a different experience. Problem is, this was a little bit limited. And the reason why is that you had to reload the entire page to get any kind of update. Imagine an experience where you're using Facebook and you click a like button on a post and the whole thing reloads. That would be pretty annoying, right? And that's actually the default behavior for a lot of HTML elements that involve submitting any kind of data. How many of you guys have worked with a form in JavaScript before and you had to put event.prevent default on it? Exactly. Reason why is because the way it originally worked was when you hit submit on a form, you would basically request a whole new page. That data would go back to the server in the form of a page request, and then you would get an entirely new page with the new data. And while it's simple, it's not that efficient, because if you have a small change where, let's say you like the post and all that changes that the heart on Instagram is now red instead of white, you don't need to re-render the rest of the content for that. And again, this was an era where internet speeds were a lot lower. So each time you refresh, you probably have to wait a second or two to get that new data in. And it's just a really bad user experience. And if really limited the possibilities of what you could do with a web page. So how would we address this? Well, we got something called Ajax, which is basically the ability in a browser to request new data without completely reloading the page. Now, we used, there used to be an old API called XML HTTP request, which was kind of the original way that you could make network calls from your browser. It was a lot more disgusting than what we have now. You had to use a whole bunch of callbacks, which any JavaScript developer knows callback hell is a very bad place to be. Nowadays, we have the Fetch API, which uses promises and async await, which are a lot nicer to work with. But as early as the late 90s, it was there. Now, there's not a single date when this became available because these APIs were implemented at different points in different browsers. Again, kind of like in the same way when you write a desktop app for your program, just a desktop app on your laptop, you have to go through the operating system for certain things like handling files or network calls. Anything that you do in the browser has to go, anything you do in a web app has to go through the browser. You can kind of think of the browser as the operating system for a web app. So any kind of network call, again, like a desktop app, you would have to go through your operating system's network IO API. You would have to go through an API in the browser to make those changes. So the API that was provided at first wasn't that great, but it did get better over time. And again, Fetch is what we have now. This is a lot nicer, and this is probably what you're used to working with if you've done some modern front end. And I'm going to go ahead and just, speaking of refresh, bring this in real quick because I had some changes here that didn't come in all the way. And so around the mid 2000s, we got something called jQuery, which was really kind of the first major JavaScript library. And it basically made working with these browser APIs a lot easier. So things like updating HTML elements on a page became a lot easier. The syntax was a lot shorter for that. It also made handling events a lot easier, making network calls with Ajax. And this was really good because, again, with different browsers such as Internet Explorer, Firefox, they might have had slightly different APIs. And especially in the early 2000s and late 90s, where the browsers were basically at war with each other, they weren't trying to make it easy for developers to work on one browser and then have their code be implemented the same on other browsers. So again, jQuery was very helpful in the sense in that it made working with JavaScript directly on the client a lot easier, although it's a far cry from what modern frameworks can do. Yeah. For the Zoom, Michael was saying this is the beginning of things that you might see in production code bases today. Uh, his first internship used jQuery on their front end. Some places might still be using jQuery. I've seen a couple of recent open source projects in the last few years that use this. Again, most places will use a more modern front end framework like React because jQuery is still very imperative in the way it works, which we'll kind of get to those differences later. But yeah, jQuery was kind of the beginning of being able to really do a lot of JavaScript on a front end because it made working with those browser APIs easier. Just as a quick example here, if you wanted to disable a button with jQuery, without jQuery, this is what you'd have to do. And then with jQuery, it sees noticeably shorter. Now, this doesn't look like much of a change, but when you have a lot of elements that are updated on a page at once, it can add up. And this made it a bit easier to work with more complex UIs. Again, jQuery on its own in the long run proves to be still pretty complicated to work with, but it was a step in the right direction. And then browser plugins. So even with server-side rendering and jQuery allowing you to change things on the fly, there was still a lot to be desired on the front end for really interactive content. And we used to use third-party plugins to do that. So the most prevalent of this was Adobe Flash. Now, again, Flash is now dead, rest in peace. But any kind of major multimedia content that you use in the web before roughly 2010 was probably using Flash. So if you played any kind of browser games, it was probably using Flash. Video, animations, pretty much anything that needed some kind of interactive content, you would use Flash for. So one of the really cool things about Flash is that it had an editor where you could build things without necessarily having a lot of code experience. It did have a coding language called ActionScript, and any kind of Flash game would have been heavily reliant on that. But Flash, you could build a website with very little code at all, and it really broke the limitations of what you could do with basic HTML and CSS. And we'll have a picture of a basic Flash website in a few minutes here, but it looked a lot less plain than what you kind of see with modern UX on websites today. And Flash is very versatile because you could make cartoons with this. A lot of online animators would use Flash back in the day, and even some TV shows would use Adobe Flash. And again, games, websites, the potential was endless with this. So again, who here has played Run? Any of the Run games? Yeah, my personal opinion, greatest browser game of all time. I don't know if anyone who here agrees with me on that, but if you played any kind of browser game as a kid, it was being powered by Flash probably. Club Penguin, a big one, Pop Tropica, and I could have probably put a million different pictures here, but if you were gaming in the browser, uh, Flash was how you did it. Now, like I was saying with interactive sites, this isn't a game here, but you don't really see websites that look like this anymore. Now, I'm sure you probably could create this with the modern tools that you have, but you just don't see it as much. Part of it is just because UX design in general in the last decade has shifted to be a lot more kind of flat and minimalist. But again, sites like these were a lot more common in the 2000s. You could say this is kind of busy. That's up for debate. I think there has been a bit of a backlash in the last few years against like super flat design. And we have seen like things like gradients, some kind of beveling and embossing coming back into web designs, but nothing to like this level of insanity. And part of the reason why is that Flash just made it a lot easier to do this than if you were doing just like pure JavaScript. And again, in the early 2000s, the browser APIs just weren't as well developed yet. And the crazy thing was, even YouTube back in the day used Flash for its video player. That just goes to show how dominant this thing was all over the web. If you didn't have Flash in again, all the way up until like the early 2010s, it would have been impossible to use a lot of the internet's more interactive content. Now, there were some other browser plugins that you could use too. Some of these were Java applets, which allowed you to use run Java code directly in your browser. This thing kind of came and went pretty quickly because Flash was so good that no one used it. There was also Microsoft Silverlight, which was C# based. Again, basically a competitor to Flash Player. But in the end, Flash was what really dominated. Now, in the late 2000s, up until the late 2000s, you basically had three kind of main ways of dealing with web development, right? You had a server-side rendering where you could have HTML dynamically generated on your backend. You had jQuery where you could update the DOM in real time, and then Flash websites for more interactive stuff. However, the late 2000s, things really began to change because of mobile. So first things first, responsive design, right? You had to have your website work on all different devices that could have different orientations and screen sizes. Now, if you look at an older site and try to like change the size of your window, all that's going to happen is you're just going to get a scroll bar at the bottom. It wasn't very well suited to different screen sizes, but that became a must-have with mobile devices because as time has gone on, more and more people have had phones. And this has been really big in an international context because as different parts of the world come online, they might not have a desktop or laptop computer, but they probably do have a phone. So their phone might be the only device that they have to interact with the internet at all. And even for people that do have computers at home, I know a lot of us probably use our phones a lot more than we did when we were younger. And I know I personally use my phone a lot more often than I did for things like watching YouTube or web searches, even if I used to use a desktop or laptop computer for that a lot more when I was younger. So the importance of mobile first design has really only increased as time has gone on. And this has had a few consequences. Number one, Flash kind of dying. So despite Flash being so dominant up until the early 2010s, you guys might have noticed that it doesn't exist anymore. As a matter of fact, Flash was completely disabled in all major browsers in 2021. Why did that happen? Well, it basically all started with Apple refusing to allow Flash Player on the iPhone. Steve Jobs wrote an entire open letter in 2010 basically saying why Flash was dumb and stupid and bad. And some of these reasons included security vulnerabilities. This is really the biggest reason. Flash had a ton of security problems, and it was also had poor performance. It could be pretty slow at times, and it also didn't have any touch support yet. Now, Flash apparently was in the process of implementing this, but with Apple basically saying no, you're not welcome here, there really was no point because then it would have just been Android only. So that basically led to Flash dying. Now, again, it was a much slower process. This letter was written in 2010. And at that point, a lot of the web still relied on Flash. But as the share of mobile users kept going up, web developers eventually realized, hey, it's not mobile development that's going to go down. It's going to be Flash. So eventually new technologies had to come and take the helm to replace it. And over time, web games kind of moved away from it. We started seeing things like HTML5. Game engines like Unity allowed you to compile directly to WebGL. And over the past decade, Flash kind of slowly died out and less content was made for it until, again, in 2021, it was removed from all browsers. And part of what made this possible was that just raw HTML, CSS, and JavaScript improved a lot. So HTML5, which released in 2008, but kind of kept being iterated on until 2014, allowed for a lot more to be added to the browser. Number one, native video and audio support. Like we said, YouTube had a separate Flash player back in the day. Not anymore, right? HTML5 is more than enough for that. Semantic HTML, which basically allowed you to label what certain kind of divs were. So, for example, let's say you had the main content area for your page. Instead of having a div there, you could have a special element called main, which would encapsulate all of that. And you had several other tags, such as, it slips my head here for a second. Yeah, header and footer. That would basically specify when you had a header and footer in your page. And this is really good for accessibility reasons because people with screen readers could parse that content a lot easier. And then a big thing was the HTML canvas element, which basically allowed for custom graphics to be written in JavaScript. So this basically killed Flash gaming because you could write games directly in JavaScript now and do advanced graphics that you couldn't do by manipulating raw HTML elements. Now there are libraries like 3JS, P5JS that allow you to kind of manipulate these graphics directly in the browser. And that is the primary way to build web games nowadays, in addition to game engines like Unity that allow you to compile directly to WebGL. CSS also got some improvements, such as media queries and animations. What media queries did was basically allow your HTML elements to look different depending on the screen resolution. So what a media query, what you can do is say, let's say you have those hamburger menus that go at the top of the page. You could write a statement that says, hey, if the screen width is less than 450 pixels, we'll collapse this menu into a little hamburger. And otherwise, we'll expand it and show the full menu at the top of the page. Now, similarly, animations got a lot better with CSS3 as well. Instead of having to rely on something like Flash, you could basically put animations directly in your CSS. Now, this brings us roughly to the mid-2010s, which is where we started to see the big frameworks that we're used to working with today. Now, these are things like React, Angular, Vue, and all these new frameworks kind of had two main common characteristics. They were component-based and they worked better with single-page apps. So what do those terms mean? Well, first off, components basically meant that we could split our UI into reusable pieces, right? Again, kind of like a core idea of good software design. You want to ideally make your code reusable, and writing raw HTML all over the place doesn't really lend itself to that. And additionally, with jQuery, you still had to manually specify what kind of operations on the DOM that you wanted. So it would be something like, okay, when you click this page, add an event listener, go and get rid of this element in the DOM, search for it by an ID, replace it with another thing. It was a bit of a mess. And React and other frameworks basically made it so that we were working with a much more declarative API. As you can see here, we're not working with any kind of IDs. We're not searching for any elements in a DOM. We basically just say, hey, here is the state. Here's how we are going to render our page based on what that state is. Another way I've heard it described is that frameworks like React made it so that your view was essentially a function of your state. And that was really good because it was a much more functional approach and made it a lot harder to kind of run into those state related bugs. And I think, in my opinion, it was really what kind of led to the shift where functional styles of programming became a lot more popular in the mainstream space. And again, if you're working with any kind of modern web development, you're probably going to see more things like this. And another big change that these frameworks brought in were the advent of single page apps. So again, before, the way a web page would work is if you wanted to go to one page of your app, you would make a request to the server. If you wanted to go from, let's say, to your home page to your about page, it would make another request to the server and your browser would download it when you click to go to your new page. However, single page apps are different because you only make one page request at the very start of your app. And typically with a framework like React, you'll only have one actual HTML file and everything else is JavaScript. So basically the app will download all of the JavaScript that it needs at the start. And anytime you go to a different route in your application, it's just going to update the UI with JavaScript instead of making another call to the server. Now, this helps to encourage a more native-like feel because instead of having to download a new page every time you click something, it's already been downloaded for you. So it feels like an app that's right on your computer because you're not waiting for the server to get back to you anytime you want a different element on the page. Now, how are we going to update our data then? Well, we just make separate HTTP requests, but instead of downloading more HTML, we just get raw data. And the JavaScript on the front end is going to determine how we change that data into a view whenever that change happens. So again, kind of going back to that whole idea of templating, That whole part where it was done on a backend, where you would fetch some data, translate it into HTML, and then send that over the network to the user, we're still doing our data processing on the backend for the most part. It kind of depends on the app. If you're doing a basic CRUD app, that's where you're doing some of your data processing. But actually determining how that data is going to be rendered into HTML, that's been shifted to the front end. Now, of course, this hasn't been without its problems. One of the first issues is that you can kind of get loading spinners everywhere. Now, why does this happen? Well, again, if we're going to download all of our UI at the start, when we first get to our website, we're still going to have to download our data separately. So if you're somewhere where you have a slow connection, you might have an idea, you might run into a situation where you go to another page and there's just a whole bunch of loading spinners everywhere because let's say this picture relied on a separate HTTP request and the bottom two pictures did, and it might come in one at a time and basically just look really bad. Now, it's up for debate on which thing is a worse user experience, having all of your web page basically load out anytime you click a button, or having this kind of slow down. But another big problem that you could get with this is bad search engine optimization. Now, the idea of search engine optimization is basically formatting our page in a way that search engines like Google can find us faster. And the reason why single page apps are bad for that is, excuse me, my throat was getting dry. The reason why single page apps are bad for that isn't necessarily that everything's on a single page, but the fact that we're loading our data asynchronously. So again, with kind of backend templating, all of the data that came on your page came with basically your UI. But with a single page app, you have to wait on a separate request to get it. So when something like Google is going to parse your HTML, it's not going to see the actual data that you have for your page. So imagine that you have something like a blog. Well, a blog isn't really going to change that much while you're reading it, right? So in that case, something like templating might work a bit better because you know that anytime you load the page, you're going to get the blog text with the HTML. However, a single page app might not work as well because you really care about getting good search engine optimization if you're writing something like a blog or a newspaper. And on top of that, you're not really dynamically updating your front end as much. So in that case, something like an old-fashioned template app might work better. However, there are some other cases where maybe you might want to have a more kind of interactive experience where you're able to change things on a front end easier, but the search engine optimization might still be important to you. This could be for something like Reddit, for example, where I'm pretty sure the way most people get to Reddit articles nowadays is because they search for a really specific problem online, add Reddit to the end of it, and then Reddit has the exact answer for you. So for them, having good search engine optimization is important, but they still need an interactive experience because you're still going and upvoting, you're adding comments in real time, and there also might be other interactive media like images and videos that you're looking at. So how do you handle that? Well, this basically brings us to the present day for web development, where server-side rendering is kind of coming back. And Next.js is really kind of the big thing that's spearheading that. What it does is it allows you to mix client-side and server-side rendering. So instead of doing basically an all or nothing approach where you either pick templating or loading everything in a single page app, you can basically load an initial React component and have your data basically prefetched with that, and then keep loading in your data on the side as you need it. Now, again, there wasn't anything that prevented you from doing this in the past. You could do this perfectly fine by having a template app on your backend and then using something like jQuery to update your page as new data came in. But it was a lot harder to work with, and the popular single page app frameworks just didn't support it well. Next lets you do server-side rendering with React. And this is really good because it allows you to basically not abandon these front-end frameworks that we've kind of become comfortable with over the last few years. Yeah, Brian. Yeah, so when I say prefetch, I mean that let's say that you have a Wikipedia article, for example, right? In a single page app, you would basically load all of the code for Wikipedia's front end. And then each time you went to a new page, you would request the data in JSON form, but you already have all of the information that you need to render the front end. And excuse me, I'm having a bit of a low blood sugar right now, so I'm being a bit more, I guess, kind of stuttery when I speak. Apologies for that. But again, the big thing with a single page app is that your UI code is basically being fetched from the server separately from your data. And that's problematic because when the search engines go to basically crawl your site, they're just going to see a bunch of empty HTML. And that is a problem because if you're, again, a site that relies on being able to be indexed by search engines easily, it can't, the search engines can't find that because that data is not going to be populated into your app until you've made that request on the page. So that's kind of what I mean by prefetch. With a traditional web page, you have the data that you want as soon as you type in a URL for it and load it. With a single page app, you don't get your data until the user takes an action specifically to load it in. Yeah. Yeah. So I can actually go ahead and just pull that up right now. So a single page app, I'm gonna go ahead and just pull up one of my old projects here. This was from Swamp Hacks last year. I did this with Michael. Yeah, I did this with Michael and Param. Um, so basically the way this app works was we had a React front end and a couple of microservices on the back end. I know we say don't use microservices for small projects, but it was a hackathon and we weren't planning to ever work on this again. And Mike and Pram wanted to work on different things. It's kind of digressing. Um, but basically the way this app works is that you would upload a picture of your face. So you upload a selfie and it matches you to a star based on your facial features. If it sounds like a stupid idea, that's because it was. We kind of started taking the project less seriously as time went on. Yeah. But basically this is how it works. So as you can see, we've got some React code here. We've got something called JSX, which is basically React's version of HTML. And as you can see, we've got a template for our data here. So the let's see, I haven't looked at this in a while, but we have components for things like information about the star that was matched to your face. And we don't get that data with the page. We have to make a separate request here. So this is using something called Axios, which is a separate library that kind of goes around the fetch API. Now, basically what's happening here is this network call to get our data does not happen until our user uploads a picture of their face and clicks the submit button. And again, for our app, it works because we don't need to be indexed by search engines. But again, if you have something like Wikipedia, that wouldn't work for you because all the data that you need Google to be able to see is hidden on your backend. And whenever you go to wikipedia.com/SSD, because SSD deserves to have a Wikipedia article, that data wouldn't be there for Google to see. It's not loaded in until you go in and load the React app. So again, that's kind of this is what the code here looks like on a single page app to load your data in. So you're making a separate call to get your data from the backend. With a templated app, your HTML comes with all the data that you have on it already. And that's why search engines are able to index it. So yeah, did that kind of answer a question? Yeah. And again, there are like I said, this was inspired by some YouTube videos. I highly recommend checking out channels like UI.dev, where they can kind of talk about this more in depth. But yeah, so Next basically allows us to mix some more popular single page app tools like React with a server side rendering and kind of get the best of both worlds there and give us a lot of flexibility. And then finally, this is a bit more bleeding edge. It's WebAssembly has existed for a few years now, but hasn't really taken over web development, and I'm not expecting it to. Basically, it allows you to run any language in the browser. Reason it's called WebAssembly is because it's a compilation target. So let's say you had some kind of desktop app that you wrote in C++. Instead of compiling it to ARM assembly, you can compile it to WebAssembly. And what that does is it allows it to run in the browser. So the browser is basically treating itself kind of as a hardware platform. Again, it's a bit convoluted, but the idea is that you're compiling your code for another language to a special instruction set that works in the browser. And again, this hasn't really taken off because it's a bit overkill. There's already such a large ecosystem around JavaScript and TypeScript that you really wouldn't need this to convert a whole lot of other devs because desktop development has kind of died at this point. But for intense apps, it could be very useful. So for example, something like Figma that uses a lot of graphics wouldn't really be ideal to do in JavaScript because JavaScript is just a lot slower. You don't have as much control over memory. And another thing is that sometimes other languages have frameworks and libraries that work better for what you're trying to do. So again, languages like C++ have had support for a lot of intense graphics for a long time. Sometimes there might be a library that you want to use that just hasn't been written in JavaScript. And WebAssembly is helpful because you could just basically use it with your app now. But again, this is more so for specific cases. This hasn't really taken off as the main way to write web apps. I don't think it's going to just because of the complexity and because JavaScript and JavaScript frameworks have already become so big. Yeah. Mm-hmm. I'm pretty sure the way I personally haven't used any WebAssembly myself. But no, C++ does not need to interface with HTML directly. Basically, the browser has an API that interfaces with it. Um, Actually, all web browsers support this. They got together and set some standards around 2017, I think. Um, but yeah, basically the browser handles that, and the C++ program doesn't have to worry. Although again, it's a compilation target. So at that low level, kind of in the same way that you might have issues trying to compile to different processors. So for example, some programs might not work as well with x86 chips as it might work if you try to compile it to ARM. It's the same problem with WebAssembly. You can kind of think of it like another architecture that you have to compile for. And that might become a problem because some C program or C++ programs might use inline assembly directly, or they might depend on some specific architecture related things because it's so low level. And in that case, you might have problems with WebAssembly support because some things are only written to work with x86. Yeah. Yeah. Uh, to really kind of understand it, you want to think of the browser as more of a platform or kind of a little mini operating system because really that's what it is, right? Anything you do in the browser has to go through. I'm sorry, anything you do on the web has to go through your browser. So network requests, rendering, the browser is like its own little sandbox. Um, mhm. Exactly. Yeah. Another good way to think of it. So you've used like desktop UI frameworks like Qt before, or I know you said have you used Tkinter, right? You uh, the one like program that you had me use when I was like testing out something for like a research project where I was writing the digits. That one was like in Python, right? Oh, that was completely in SFML. Wow. Okay. Yeah, I could have sworn you said it was in like a desktop framework. Well, anyway, a good way to think of the distinction is if you're writing an app in like C++, right? If you're just writing a typical desktop app with buttons and forms and all those typical UI elements, you wouldn't want to use SFML because you would have to basically remake all those from scratch, right? A framework like Qt has all those UI elements for you already. But if you're building something like a game where you really need to customize the graphics, you would use something else like SFML, right? And that gives you access to more level control over individual pixels and shape drawing instead of being confined to basically how do I make a button or a div look like a person or a character that I'm rendering for a game. So I think that's a good analogy for the difference between plain HTML and WebAssembly. WebAssembly allows you to basically bypass HTML because the browser has provided support for it. In the same way that when you're writing a desktop application, if you're doing a game using something like SFML or other libraries like SDL, allow you to basically work with the computer's graphics at a more low level instead of using plain buttons. Mm-hmm. That that honestly, that is a good question that I don't know the answer to personally. I haven't done a whole lot of WebAssembly, but I did figure it was important enough to include like in the presentation. Uh, and really, that's the reason kind of why I thought this would be an interesting topic. Again, we're all in college. Most of us have only been writing code for a few years, if not less. So a lot of us haven't understood what it's like to work with some of these older technologies. I know I personally have done front end in almost exclusively React. So a lot of these older ways of doing server side rendering, templates, jQuery, or even Flash development, even though I'm sure we all grew up using websites that use these tools, we've never actually developed with them. So uh, while I personally have not done WebAssembly development with WebAssembly, I think it would be probably a good exercise for the reader to maybe pick out some sites that use it, maybe try to inspect it and see what's there. Yeah. By the way, this is the last slide. So any more questions? Yeah. I yeah, yeah. So it's completely sandbox, like if that's what you're asking. So like a C++ program and WebAssembly like can't access your computer's file system like with without permission, right? Um so it's not like if you downloaded a C++ program on a computer and then ran it and it could pretty much just wreak havoc, right? It's completely sandbox. Yeah. Yeah. And the really cool thing is that this technology has like allowed more modern plugins to work without having to rely on basically external plugins. So, for example, something like Flash back in the day, right? You had to download and install that separately from your browser. Like it wasn't even something that you could download as an extension, like in a Chrome web store. You had to download it onto your computer and install it. And whenever you, for example, ran a Flash game, Flash would start up as a separate process on your computer. That's completely separate from your browser, but it's just displaying inside the browser. But what WebAssembly will allow you to do is have these different processes that are kind of running in your browser based on this code, but it's not a separate thing. Like you don't have to download, for example, Figma. You don't have to download a separate plugin to run Figma. It just works with your browser. And several browser extensions like Ruffle, for example, which is actually a Flash player emulator that you can use to still play some Flash games now. It works with Rust and WebAssembly. So that's, again, one of the real big benefits of it, just from a security perspective. Because, yeah, imagine like if someone could just like put some, write a C++ program, compile it to WebAssembly, put it on a web page, and then access your file system. That would be vulnerability of the century. Yeah. All right. Again, I don't have any more content. So like any other questions, concerns, feedback? How do we feel about the a whole like kind of double workshop format? Thumbs up or down? Awesome. Yeah, so we'll go ahead and stop the recording here.